In the diagram below, prove that triangle EFG is congruent to triangle EIH. Let's start by highlighting our two triangles. Let's make triangle EFG red and triangle EIH blue. We can also write down our 4 possible reasons for congruency at the top of the page. Now we can consider the diagram. Straight away, we can see that we do not have any 90-degree angles. So let's take RHS out of our list of possible options. We can also see we've been given 2 pairs of equal sides, which means that we need to find a third pair of sides or a pair of angles. So we will not use AAS as a possible reason. So let's take this out of our list as well. In the diagram, we can see that EF is the same length as EI. E and F are the first 2 letters in triangle EFG. E and I are the first 2 letters in triangle EIH. So these are corresponding sides. So we can make the statement that side EF is equal to side EI. We know that this is true because this information has been given to us in the diagram. We can also see that FG is the same length as HI. F and G are the second and third letters in EFG. H and I are the second and third letters in EIH. So these are also corresponding sides. So now we can make the statement that FG is equal to side HI. This has also been given to us in the diagram. And now we define 1 pair of sides or 1 pair of angles. The diagram tells us that angle G over here is equal to angle H on this side. But these angles do not sit in triangle EFG or triangle EIH. So we cannot consider them as possible corresponding angles. GH is also not an extension of one of the triangles we've been working with, so we cannot consider them as external angles either. But both angle G and angle H sit in triangle EGH. So let's make this triangle green. Now we can say in triangle EGH, we know that angle G is equal to angle H, and this information has been given to us. From our work with triangles, we know that if a triangle has 2 interior angles that are equal, 2 sides are equal as well. In this triangle, angle G is equal to angle H, which means that side EG must be equal to side EH, because triangle EGH is isosceles, and these are the sides that lie opposite equal angles. On our diagram, let's mark these equal sides with 3 blue lines on side EG and on side EH as well. EG is also a side of triangle EFG, so let's make it red again. EH is also a side of triangle EIH, so let's make the side blue again. And now we've found that 3 pairs of corresponding sides are equal. So we can say that triangle EFG is congruent to triangle EIH because side, side, side.